Hey everyone, I've been doing a lot of malware analysis and working on some videos surrounding that, but I thought I'd do a quick video just on around the lab that I use. So here's the main architecture for the lab I use. So I tend to use VMs. Um, I run both the malware and the tools to analyze the malware on these VMs. Rather than doing so on my development host, I like to have a segregation when it comes to uh, downloading and running any sort of malicious payloads and keeping them away from my host development machine. Um, Quite an advantage to that, disadvantage as well. So disadvantage being that some of the malware that I've been looking at has anti-debugging and anti-virtualization built into it, so it knows when it's on a virtual environment or some types of virtual environment, and then will just sit there inert and not actually manifest itself at all. In those situations, I'll go into more detail in other videos, but rather than edit the payload, sometimes you have to run it on a physical machine. I've avoided doing that at the moment, so I run everything virtualized so that I can do snapshots of the machines at various intervals. And if I end up going down a bit of a rabbit hole, I've got the opportunity that I can wind it back and kind of take a look at how I got to a certain point from those snapshots. Um, so I've been looking predominantly at Windows-based malware. So the VMs I've been running mainly to execute that malware have been Windows. So I think a good practice is to have your development host on a different platform to that. That way, if your malware kind of breaks out of your virtualized environment, it can't really get too far. This particular lab, I've switched over to use a Mac. You could use anything else, so you could use a Linux box running something like VMware or VirtualBox on it, or another thing that I've done is I've actually had this development host as a VMware ESXi, and then had all of this virtualized on there. I've not done that for most of the videos that I'm going to be uploading. That's because my ESXi host is quite underpowered. It's quite low on resource, and a lot of the tasks that I was performing for malware analysis were actually taking quite a long time on that host. Um, so as far as the virtualized software is concerned, you can run whatever you want. So I've tested quite a few things. I ran Parallels, VirtualBox. I'm using VMware Fusion at the moment. Um, I'll do a few videos later on to do with memory extraction from the virtualized layer, and that seems to be a lot easier with a lot less steps for VMware. So although VMware is more expensive, well, it's relatively cheap when you kind of weigh it up against the time that you're spending doing the analysis. So it's worth the investment for the cost. Uh, I did use VirtualBox for quite a while. It crashed quite a lot with a lot of the tools I was trying to hook into it. So I kind of gave up on that. But there's always that option. Um, The firewall that I'm running on here, I'm running an off-the-shelf software firewall. You could run whatever you want, whether it be a Linux box with some kind of web proxy on there like Squid, or some kind of routing setup through it. I've got two networks on the virtualized layer. I've got one which is a NAT to host network, so only the firewall can speak to that NAT network, and that NAT network goes straight through the development host and out to the internet. And the firewall's then got a second network interface, which is connected to a host-only network. And the host-only network have got my VMs on it, and they use the firewall to talk out through the internet, so I can actually see what's going on and make sure that nothing is leaking out that I wasn't aware of. As far as the machines are concerned, I run a Linux machine and I run a Windows machine. So the Windows machine will execute the malicious payload, and I tend to point things like DNS and common services over to the Linux box. That way, I can be monitoring on this Linux box while the malware is executing and see exactly what sort of requests it's making out to the internet. I can see exactly what kind of services it's accessing, and the services that we run on there will actually talk back to the Windows box if there's a request made. This host-only network, by default, when you create it, also has the development host accessing it. That's quite handy, and it will be handy in a minute for accessing the Firewall's web interface. However, it does mean that if you're running a Windows box on your development host and you're running a Windows VM here, and the malware that you're testing has any sort of capability to spread like a worm, make sure that your development host is fully up to date, patched, and has antivirus. Even on this Mac, I make sure that I've got antivirus the minute I'm using ESET, but I switch antivirus vendors quite often. So the Linux machine that I'm running is an Ubuntu machine. I'll show you in a minute exactly what version of that I'm running and why. And on the Windows side, I'm running a Windows 7 image. That's predominantly because the malware that I've been looking at, although it's quite clever, it's not very new. So I didn't need any of the new functionality or APIs in Windows 10. It would have been a pain to have to turn the built-in antivirus off of Windows 10. So with Windows 7, I know the malware is going to work, and I know that I don't have to do any sort of configuration to the actual box as it's spun up. All I do is drop my tools on there and then start analyzing. So the firewall that I'm running is I'm going to be running the Sophos UTM Home Edition. One of the reasons is it's free, and the second reason is it's just been on my list to kind of have a look at and have a play with. It's got a load of next generation stuff such as web filters, and it's got antivirus and stuff built into it. So it's been on my list to take a look at that, and I think while I'm building a lab, why not have a look at it at the same time if it's quick and easy to use. From the Linux machine, I'm going to use Ubuntu, and I'm going to use Ubuntu Desktop. I usually use Server Edition because it's a lot quicker to install and it's a lot lighter, but there's been a few instances with this malware analysis where it's been handy to have a UI on the box just to be able to spin up the UI for some tools and a browser without having to export the displays for those tools through to the development machine and expose it to that network. And then lastly, I get my virtual machines for Windows from Microsoft. A lot of the malware analysis I've done previous to this, I've been looking at the effects some malware has on the DOM. So it's actually been quite handy to have a 90-day evaluation of a Windows OS that's got these browsers on it. For this particular lab, I've got Internet Explorer 11 on Windows 7. What's great is they're packaged up all ready for you to deploy to your virtualized software. So I've picked the VMware Windows at Mac. So I think looking at this, we're ready to start spinning up the environment. So what I'll do is so far I've set up a private network for the host-only network. I've turned off DHCP on that because I actually want the firewall to hand out IPs and routes to these boxes. That way, if I spin the firewall up first and then spin up these boxes, they'll automatically be configured so they go through the firewall to get to the internet. And I want to connect the host Mac to the network. so that I can get to the web interface. So on a firewall, you've usually got an untrust side and a trust side, and your web interface for accessing this firewall is usually on the trust side, because you don't want people on the internet trying to hack through to your web interface on your firewall. So let's spin up the firewall. So we're going to create a custom machine. I have no idea what OS it is under the hood, so we'll stick with Ubuntu 64 and just see what it does. Create a new hard disk. I don't remember what the system requirements were. Okay, they're not on this page, but I have a vague recollection of what they were. So we need to save it first. I like to call it Firewall 1. So hard disk wise, it needs 60 gig because it creates quite a lot of logs. It needs more processing power. It needs way more RAM. I can't remember how much it needs, but for now we'll just give it 4 gig because I don't want to overload this poor machine. Network wise, it needs one network card that's sharing with the Mac, and then it needs a new network adapter that is on this private network, and it's got the IP range for that private network as well. So that's we'll need to set an IP on this firewall in a moment when it's booted up, and we'll just need to set it in this range. So it's got 77 in the 3rd octet, so that's fine. So what we'll do is before we spin that machine up, let's just spend a little bit of time creating the shells for these boxes, because we can have them spinning up in parallel just once this firewall has got a bit further. So if we add a few more boxes, so let's spin up the Ubuntu machine. So that's going to be Ubuntu 64. Pretty much happy with the resources on here for now. I mean, just for argument's sake, I might give it a little bit more RAM just so that it builds it quicker. So I like to call my machines forensic, and I usually leave reserve 1 for the main machine that I'm infecting. So this is going to be called forensic 2. And we'll give this a little bit more RAM, give it a little bit more grunt just so it installs a bit quicker. And then we've got one more machine, which is, well, the good thing is about the Windows machine is it's already built for us. We just need to import it. So there it is. It's detected in my downloads. So I'll just import that. I'm going to call that forensic 1. So that's going to take a little while to import. So let's spin up our firewall and see how much work it is to build one of these Sophos firewalls. Okay, so it's not detected the CD yet because I've not connected it. So let's connect the CD. So that's that. And we want to connect that CD, and then we're going to need to restart. So yeah, we're happy that it's going to wipe this device. I'm going to set it to UK, that way the time is going to sync with my nearest NTP server. Select which interface you want to access the web interface on, so we want it to be on the 2nd interface. That'll be the internal one. And I think we said that the 3rd octet was 77. Do we want 64-bit kernel? Why not? We spun up a 64-bit machine, why not use it? And do we wish to install all capabilities? Yeah, of course we do. We want to play with all the toys. And are we happy it's going to erase the disk? Yes, we're happy. Excellent. So while that's wiping that firewall, let's go and just have a look at these machines. So this is my Windows machine. Having a look at it, so it's quite underpowered. So I like to give it a little bit of resource. It's going to be running malware. So the memory is going to be the main thing. So I've got to balance this memory, give it enough memory to run the tools that we want, but not so much that if we try and dump the RAM out of this, that we can't do anything with it. So for now, I'm just going to give it 2 gig of RAM. It's got no network card, so we need to add a network card, and we need to put it on that private network. Okay, so that's that. At the same time, let's also just double check the Ubuntu box that we put it on the private network. So we didn't. So let's pop that on the private network as well, and then we don't have to worry about that later. And in fact, while this firewall's installing, let's install the Ubuntu box, because that could take a little while. If it's not finished by the end of this video, then we won't worry too much, because we can do the majority of our testing that this network infrastructure works by testing the Windows box, and that it can get out, and that it goes out through the firewall. Okay, so we need to first of all connect the ISO for Ubuntu. The server edition installs really fast. The desktop edition has quite a lot more to install, so I won't be surprised if we don't see this installed fully. Yeah, we don't care that something else is using CD-ROM. Okay, that beep means the firewall is done. So we'll just get this going. Happy for it to erase the disk. Time zone is UK, London. Happy with that. Your name is Bob, and username is Bob. To the password, we're going to go for the super secure password of Bob1234. Okay, so that, I didn't bother changing the computer name, but that's fine, I can always change that later. So here we go, so the firewall has finished installing. So it says after reboot, it should be available on this particular IP here, which is what we expected. So let's reboot that. And let's drag that over here a bit so we can see it a bit better. And if we do F2, you can see what it's doing. So that's fine. It's booting up. Everything is starting up fine. Okay, so that's spun up. Let's try and get to the web interface on that. So it was a secure channel to 192.168.77.100, and that's port 444. So it's got self-signed certificate, that's perfect. And it's asking us to set up a wizard, so let's have a look at that. So this is Firewall 1. Don't really company, don't really care about that. So in the United Kingdom, admin account password. So I'm going to use a super secure password of admin1234, and email address of ds@gmail.com. And that's just thinking. Let's see how our Linux box is doing while that's thinking. It's taking its time. Okay, so that's finished. What I may do is I'll leave that alone for now. Okay, so the firewall has finished restarting. So admin with the super secure password of admin1234. It's asking, it's giving us the option that if we're kind of restoring a firewall, that we can restore the backup, but we don't care. So I don't have to input my license file straight away. That's good. So you can run this for 30 days without the license. So that's great. We can do that later. The internal LAN is the one that we set up. The network interface is going to be the network uplink is going to be our second interface. It's a standard Ethernet. It's DHCP, so that's fine. Let's leave that. What services do we want to allow out? Well, we actually want to allow probably all of these for now. We can lock them down later. Don't really need that. Oh, that's pretty cool. That's pretty cool. I'm going to be playing with that probably a bit later then. So some of the next gen stuff in this. Oh wow, that is quite cool. Yeah, awesome stuff. Play with all that later. So yeah, so that's that. Okay, so we've got the firewall all set up. Let's set up a DHCP server, because I didn't set one up a minute ago. So one new DHCP server on the internal interface. Start range, well, our host is .1, so I'm going to start at 200 because we're never going to have 50 odd hosts, so that should be fine. DNS server is going to point to the firewall. Default gateway is going to be the firewall. So yeah, so let's save that. Okay, so we've got DHCP server. So that's the firewall part of this diagram now set up and ready to route traffic. So we're going to spin up the Windows box because that one is quite a quick one to spin up. Okay, so I'm not too worried about the virtual hardware being out of date. To be fair, I'm probably going to remove the virtual tools anyway because it's just another indicator for malware to detect that it's on a virtualized host. So I usually remove that and just take the performance hit for doing so. So while this Windows machine is booting up, let's figure out what's going on with this Ubuntu box. Let's give that a restart anyway. Just trying to get it online a bit quicker for us. Get it to skip whatever process it's running through. Okay, so the Windows box is online. We don't want to reboot anything yet, and we're on a home network. What I'll do is I just want to let it get on the internet and then check that we can get through to the internet. So if I do a ipconfig and try and scroll down, start later, we see that we've been given an IP within the range set in the DHCP server. So that's good. Our primary routes out, and the DHCP server is the firewall that we set up. So that's good. So we should be able to get out to the internet on this Windows box. Let's look for Chrome download. The first thing you always do with Internet Explorer is working out how to download Chrome. Okay, so that can get out to the internet. That's great. So Bob is so the password for this one was a super secure one, which is Bob1234. Just so you know, the password for the Windows box is usually on the screen, and it's